Hello, welcome to part 3, spinal cord repair. Today's topic will be the human nervous system and just the basics of it. The human nervous system consists of two major systems of carrying nerves and impulses throughout the body. First one is the central nervous system and the second one is the peripheral nervous system. The central nervous system consists of the brain and the spinal cord. And remember, we talked about in part 1, we said that the spinal cord was roughly the size of a tube, one of these drinking straws. In it, the brain is actually extruded, pushed into this tube, and goes all the way down the body to the base of your spine. And inside of that is the spinal cord. Leaving but not touching the central nervous system is the peripheral nervous system, and there is the nerves that go to the feet, the arms, the fingers, the heart, lungs and the rest of the organs throughout the body. Encapsulating the central nervous system is what's called the blood-brain barrier. Now, just like in part 2, we can consider this just like the baby in the placenta. So here we have the human blood supply, but internal to it is this, just think of it different like the baby in the womb, and it's protected and isolated from the rest of the body through this blood-brain barrier. In actual fact, you have blood supply to your head, but your brain does not have blood. It has an exchange of nutrients via this barrier, and later on in probably part 10 or something we'll talk more about this blood-brain barrier, but today this is just an introduction. Now let's start thinking outside the square again, like we did in part 2. I want to bring you up to speed on thinking outside the square. This is a different animal to this. Your brain is, think of it as a different person inside you. It has a different immune system. So also in part 2 I briefly talked about the T cells, which were the specialised cells of the immune system that are used to control the body and defend it against invaders, and also it has another function, that is to clean up dying cells or cells that have become malignant, have cancer or defective. Now what happens is we have round about here we have an organ called the thymus gland. And the function of the thymus gland is to educate these cells of the immune system, particularly these T cells. Remember I talked about cluster definition, CD4. Now what happens in the thymus gland is that inside your bone marrow, these T cells are formed, and they travel into this thymus gland to be educated, and they branch off into two sections. One is look after things like viruses, and to be educated about killing viruses and bacteria that enter the body, and that's the other section is the programmable section, which looks after the body. So that looks after this cleaning up things in the body. We have a cancerous cell, it cleans it up. Now if the thymus gland gets out of whack, you start developing autoimmune diseases. You start where the body will start, the immune system will start attacking your body, and you'll things like diabetes, where it attacks the small cells in the pancreas that create insulin, the islet cells. It may attack the joints, rheumatoid arthritis. And this thymus gland needs to be reset. Now, we won't talk about this time, but the thymus gland, if it gets out of whack, it will start destroying the body. But a healthy thymus gland and a healthy immune system keeps the body in check, killing invaders and keeping the body free of cancer and defective cells. So that's the balance. Now, what happens in a spinal cord injury? Say we have a car accident and a sharp object breaks this section of the spinal cord. What happens is the most traumatic thing, believe it or not, is not the injury from this sharp object. The biggest trauma is the body. It sends these T cells into here, the ones that have been programmed, and they start attacking this section of the spinal cord, creating a mass of scar tissue. Now, this shouldn't happen. If the brain and the body were the same animal, the immune system should say, well, this is a healthy cell, I shouldn't be attacking it. But the immune system attacks it. So there's our first clue. And this is where I want to start thinking outside the box. We've got two different animals. We are composed of two different animals. And if you are in any way religious, you also have a soul. So there's a trinity here to make up the human body. So I had a lot of difficulty understanding this when I first started learning about the nervous system, and no one described this to me in this way, and I was quite shocked. So I pondered it for many weeks, and then one day I had a dream, and I sort of came into this dream where back in the primeval swamp there was different animals floating around, and there was two types of small singular cellular animals, say, and one was intelligent and one was big and strong, and they bound together and formed this union between the two, and that's sort of how my impression of life evolved, from two creatures. And this creature here, the intelligent one, communicates to this big strong dumb one with various chemicals. So if the basic analogy, it's a bit way out there, but it may help you. But the main thing is today is to start bringing you into this world of thinking outside the box. And if we're going to cure this spinal cord, if we have to regrow it, we can't keep thinking along the same lines that we have. And as I said, as I was describing my part one, the small glass scalpel, it is a method that we will actually come in here and cut this section out and rejoin it. But to do that, there's a lot of other processes that you have to get through and understand. So I'll get into that next part 4, which will be some basic introduction to the spinal cord and electricity and how it analogy of using the spinal cord and electricity. They're very similar, but I'll do that in part 4. So thanks again for watching.